So you might have heard about the Euler's number, or E, but what is it exactly and how do we compute it? This Python function does that, sort of. We'll get there in a minute. So it takes a positive integer as an input and uses this formula to produce an output. The formula is very simple. It is just 1 plus 1 over n, all raised to the nth power. So let's use this formula to compute E. Actually, the greater n is, the more precise E is. Take a look. So I created this simple loop, which iterates from 1 to 999 and outputs and prints the formula and the result of the calculation. So as you can see, when the input is 1, the result is just 2.0. When the input is 2, the result is 2.25. And the larger the result is, the more precise the output is. And as we can see down here, the most precise number is 2.7169, etc. So you probably see where it all goes. And you might be wondering, so is it impossible to compute the exact number, right? Yeah, it is impossible. But the number actually exists. If we go back to the definition of real numbers and the theory behind it, there are real numbers that we can't compute. Take square root of 2 as an example. But the theory manages to give a precise definition and make such number real and really existing. Well, going back to the Euler's number, the rigorous math proves that there is one and only one real number that our function approaches, that this sequence approaches. And that is what we call an Euler's number. But remember, that number exists, even though we cannot compute it, just as the square root of 2. So at the end of the day, the Euler's number, or E, is an existing real number that our function calculate E approaches when n grows up indefinitely, when n goes to infinity. And there is a one precise real number that we call